Alright, well I'm going to go through and solve a whole bunch of problems from the Mod 9 review, and this should help a ton, so let's get cracking. Okay, you definitely want to have all of the properties memorized on this particular flow chart, and remember when you have a quadrilateral, so it starts right here with a quadrilateral, and that's just any figure that has four sides. As soon as it's a parallelogram, it has all of these properties, and then underneath that, if it's even more special than just a parallelogram, then it's a rectangle. If it has one right angle, actually has four right angles, and or if the diagonals are congruent, then that makes it a rectangle as well. If it's a parallelogram already, and you want to see if it's a rhombus, then you would have to see if it has one of these characteristics. So either the diagonals are perpendicular bisectors, the diagonals could bisect the angles, or you could have two consecutive sides. And then the combination of a rhombus and a rectangle would form a square. So that's a really special, very special quadrilateral. And then these other ones are very separate. So a kite, totally separate, so you have to look at those characteristics. And then we have the two separate ones here, the trapezoid and the isosceles trapezoid. So really spend time memorizing those properties. Okay, so the first learning target, mainly all the properties of parallelograms. The basic definition of a parallelogram is a quadrilateral. Quadrilateral what? Quadrilateral that has both pairs of opposite sides parallel. So quadrilateral with both pairs of opposite sides and that makes sense because it's called a parallelogram, so parallel, so just think that way. Okay, then the properties of a parallelogram, it has four kind of extra properties besides the fact that the two opposite sides are parallel. It has the opposite sides are congruent, so that's super important. That's used a lot. So opposite sides congruent, I'll just use that symbol. Opposite angles are congruent, so remember that. Opposite angles congruent. And then we have adjacent angles are supplementary. So adjacent angles are the ones that are right next to each other. So adjacent angles, supplementary. Now remember what supplementary means? They add up to be 180. So two angles right next to each other add up to be 180. That's different than when they're straight across from each other. So keep this kind of picture in mind, you know. If you have a parallelogram, the ones that are opposite each other here, these are congruent. But if they're right next to each other, like this one is right next to this one, those are the ones that are supplementary. Okay? Alright, and then the fourth property is that the diagonals always bisect each other, so they cut each other in half. So diagonals bisect each other. Alright, okay. Alright, let's get to some solving here. So for this parallelogram, it looks like we have angle 2 is listed, 5x minus 28, angle 4. So we have these two are given to us right here. So angle 2 and angle 4. Now we know we can solve this problem because they're opposite angles, so that means that they are congruent. So let's go ahead and set up an equation to solve it. So let's say 5x minus 28 is equal to 3x minus 10. And then we just get to use our good algebra skills. So I'll try to explain some of the algebra skills, but definitely see me, like if you're having trouble with some of the basic algebra that we need to solve these problems. So minus 3x from each side. So that'll give 2x minus 28 equals, looks like negative 10. And then next I would add the 28. So that's going to give us 2x equals 18. And then I would divide by 2. Okay, so we got x equals, I got 9. Okay, now I need to make sure I answer the question. It says find angle 3. Okay, so I haven't even found any of the angles yet. So I'm going to find angle 2 first, because angle 2 looks like it's listed as 5x minus 28. So I'm going to go ahead and plug in the x value there. So we figured out that x is 9, so that's going to be 5 times 9 minus 28. So that equals, what is that? That is 45 minus 28, so that's 17. So 17 is how much angle 2 is. Okay? Now, if this one is 17 degrees, then this one is right next to it. That's the one that's supplementary. So what I have to do is just do 180 minus 17, and that's where I get the angle 3. So for angle 3, it equals 180 minus 17, which is 163. So that's what we want for angle 3. Okay? Alright, this one is LMO is a parallelogram, so I definitely would, if I don't have a diagram, I really need to draw the diagram. So I draw this one, so this is L, M, N, O, and then this also has diagonals, so I'm going to put those in there. And it looks like they intersect at point A, so I'm going to put that there. And then I'm going to start labeling this thing. So LA is 5x, NA is 3x plus 8, and then it says that MO is the whole length here, so I'm just going to list that MO is 9x. Okay, and we're supposed to figure out what MA is. Alright, so what happens with parallelograms is one of the properties that we listed just a little bit ago is that the diagonals actually bisect each other. So that means that the 5x here is equal to the 3x plus 8. They cut each other in half. So let's go ahead and make that equation, and let's say that 5x must equal 3x plus 8. And then we'll solve for x. So subtract 3x. So that'll be 2x. And then equals 8, divide by 2, so x equals 4. Now if x equals 4, that should help us. We could actually figure out what this whole length is here. And so MO is that whole length, which is 9x. And we can take the 4, which is what x is, so we could do 9 times 4, and that's 36. So that's MO is 36. Now, we were looking for MA, so that's half of that. So if MO is the whole thing, then half of that is 1/2 of 36, which is 18. So MA is 18. Okay, again, 1/2 of 36. Okay, the next learning target is that you could prove a quadrilateral is a parallelogram. So let's get to some of those. So if this is really a parallelogram, then there's certain things that are true about it. So let's go ahead and label this diagram. So ON, 5x minus 4. LM is 4x plus 7. NM is x minus 7. OL is 2y minus 6. Okay, So because this is a parallelogram, that means that the opposite sides are congruent. So that's the property that I would list. I would say opposite sides congruent. That helps us set up the right equations. Okay, so the first equation is 5x minus 4 is equal to 4x plus 7. Okay, now we're going to solve for x. So let's subtract 4x. So that would give us x, just 1x, minus 4 equals 7. And then add the 4. So we got x equals 11. Okay, so x equals 11, that's good. We want to find the values of x and y, so bam, we already found one of them. Alright, the next equation we could set up is the fact that the other two sides are congruent because they're opposites, from each other. So 2y minus 6 is equal to x minus 7. Now we already know what x is, so that means we could actually put it in right there. So let's set up the equation plugging in that x. So this would be 2y minus 6, and for the x we're going to put 11. So that would be 11 minus 7. That will help because then it'll only have y's in there instead of x's and y's. So 2y minus 6 equals 11 minus 7 is 4. And then we're going to solve for y. So we're going to add 6. So that would cancel out. So then we'd have 2y equals 10. And then last thing, just divide by 2. So make it really small. So divide by 2, running out of room. So I say y equals 5. Okay, sound good? Alright, I think we covered everything on that one, yeah. Alright, next one. How can you prove that a quadrilateral is, something special like a parallelogram? So 3 good ways. Actually, there are 4 good ways. So let's go ahead and list the ways. One thing you can do is you can show that both pairs of opposite sides are parallel. That will immediately show that it's a parallelogram because that's the definition of a parallelogram, that opposite sides are parallel. So let's write that. So both pairs of opposite sides are parallel. That's the symbol for parallel. Okay. Second way you could show that it's a parallelogram is you could... No, I have the same thing listed twice, sorry about that. One pair of opposite sides is both parallel and congruent. So you can do it that way too. So you can say one pair of opposite sides is parallel and congruent. So that would mean, the picture of this would mean if you had sides that are across from each other, like these, if they were parallel and they were congruent, that would be enough to show that that's a parallelogram. Versus the first one that we did, we said we would have to show that these are parallel and then these are parallel. That would show... Sorry, I gotta turn my phone off here. It's bugging. Okay. So, yeah, so these opposite both would have to be parallel, these would have to be parallel. But if you're just working with one set of sides, you'd have to show that it's congruent and it's parallel, and that would be enough for a parallelogram. And then the third one is that if you could show that the diagonals actually bisect each other, that would be enough. So diagonals bisect each other. And again, kind of picture of that one, these are the diagonals, and so then they cut each other in half, so that would show that they're being cut in half. Okay, this proof I'm actually going to skip because it's just not as similar to what we've got on the SLED. So I'm going to give you kind of a different one here. just to save us a little bit of time. Okay, if these two triangles are congruent, how can we show that this whole thing is a parallelogram? Well, if these two triangles are congruent, let's go ahead and kind of set up our proof. So it's going to be just a few steps here. So first thing, we always want to list the given. So let's say triangle MJK is congruent to triangle KLM. How do we know that? That's given. Okay. Now, if those two triangles are congruent, we know that all the parts are congruent. So if all the parts are congruent, then that means that this side would be congruent to this side, right? And so we can go ahead and list that. So let's say that MJ would be congruent to what? KL. How do we know that they would be congruent? Because whenever two triangles are congruent, all the corresponding sides are congruent as well. All the corresponding parts, right? So we call that CPCTC. So that's corresponding parts of congruent triangles are congruent. Okay. Now the other thing that would be congruent are these two sides. Okay, because they're straight across from each other. They are corresponding sides, and so we would be able to say that KJ is congruent to ML. And why would they be congruent? Because of CPCTC, because they're congruent triangles. So remember, from the beginning, this triangle is congruent to this triangle, so all the parts are congruent. So now, if we have those two things true, then we can tell that this whole thing is a parallelogram, because we have the opposite sides are congruent, we have these two opposite sides are congruent. We're like, oh man, this thing's a parallelogram. So that would be it. We would say MJKL is a parallelogram. And how do we know it's a parallelogram? Well, because both pairs of opposite sides are congruent. So if both pairs of opposite sides congruent, then it's a parallelogram. Okay, next. So 9.3, so rectangles, rhombi, and squares. Okay, definition of a square. Alright, what is a square? So a square is a parallelogram with 4 right angles. So parallelogram with 4 right angles. Okay, what are some properties of rectangles? The main one that's added is that the diagonals are congruent. Okay, so diagonals are congruent. That's how you can differentiate. If it's a special parallelogram, like a rectangle, diagonals are congruent. Okay, what about a rhombus? Well, a rhombus is a parallelogram, of course, but it has special characteristics, like the fact that it has 4 congruent sides. So 4 congruent sides. Okay, so let me just add before that it's a parallelogram. So parallelogram with 4 congruent sides. Okay, what are the extra properties of parallelograms, or of rhombi? So the extra 2 things are that the diagonals are perpendicular. So the diagonals are perpendicular. That's the symbol for perpendicular. And the other thing that's special is that the diagonals actually bisect the angles. So diagonals bisect angles. Okay, we'll see some examples of those solved. Okay, and then a square is basically the combination of a rhombus and a rectangle. So a square is a parallelogram with 4 right angles and 4 congruent sides. So it's the perfect combination of a rhombus and a rectangle. Alright, let's get to some solving. So find the value of the numbered angles in the rhombus. Okay, so what really helps is the property that says that the diagonals intersect. They bisect each other perpendicularly. So these are a bunch of 90-degree angles here. So let's go ahead and solve this one. So let's see, we got 90. So let's try to find angle 1, because it looks like, no, actually let's do angle 2 and 3, because that's quick, right? So angle 2 is 90 degrees, and then angle 3 is 90 degrees. And then if we want to find angle 1, we would say angle 1 plus angle 2, but now we know angle 2 is 90 degrees. So angle 1 plus 90 degrees plus 52 degrees has to equal 180. So always look for triangles. So when you look at this and you see, hey, this is a triangle, you know all triangles add up to be 180. So this one is, we already have the 90 there, so we're going to add those together. So we got angle 1, plus, and this would be 142 equals 180. So angle 1 must equal whatever 180 minus 142 is, which is 38 degrees. Okay, so we got 38 degrees for angle 1, and then actually you could say, remember how the diagonals actually bisect each other? So 1 is the same as angle 4, because their opposite angles are congruent and they bisect each other. So we're going to say that angle 4 is 38 degrees. Okay, that would be the quickest way, just recognizing, you know, that these whole angles here are opposite each other, they're congruent, and then they're bisected perfectly by the diagonals. So, alright, so similar deal here. What's going to help us state the property that that helped you find the angles? We're going to say that diagonals are perpendicular. Okay, so diagonals are perpendicular. Same property that helped us on the last one. So right away, it looks like angle 2 is going to be 90 degrees, right? This one here. So that's 90. And of course that's 90. And then the diagonals for a rhombus, the diagonals bisect the angles. So that means if that one's 70, then so is that one. So 70 and 70. And that means if we're looking at this triangle right here, that would be 180. So that means that only leaves, that's 90 plus 70 is 160. So that means angle 4 has to be 20 degrees. And then if angle 4 is 20 degrees, then so is this one, because this diagonal here has to bisect the angle. So that means angle 1 has to be 20 degrees as well. So the property, we're going to say, let's say 2 properties, because one of them is that the diagonals are perpendicular, and then the other one that really helped us is that the diagonals bisect the angles. Okay, 9.4, so you can read that. Alright, so let's get to some of these questions here. Both pairs, so is it always, sometimes, or never? I know these are a little bit tricky sometimes. Both pairs of opposite sides are parallel in a rectangle. Yeah, in a rectangle is a parallelogram, so of course it would have the opposite sides being parallel. So this would be all the time. Okay. Next one, diagonals are congruent in a rectangle. Okay, this would be all the time, so that's true of a rectangle. That's something special, the diagonals are always congruent. Okay, diagonals are congruent in a rhombus. Not really. They really don't need to be, but we could say sometimes, because if it was a special rhombus, like a square, then the diagonals would be congruent. A square is a rhombus, yes. So a square is definitely always a rhombus, at least. It's more than just a rhombus, it's a rhombus and a rectangle. The next one, a rectangle is a square. Sometimes a rectangle can be special and be a square, but a rectangle doesn't have to be a square. A square is definitely a rectangle, at least. Adjacent sides are congruent in a square. Yeah, absolutely. So adjacent means right next to each other, so they definitely are congruent in a square, so this is all the time. A parallelogram has at least one right angle. No, it doesn't have to at all. It doesn't have to have any right angles. If it does, then it's a special parallelogram, like a rectangle, or it could be a square. So this would be sometimes. A rhombus has perpendicular diagonals. Yeah, that's true. So a rhombus has the diagonals, they meet up, and they form the 90-degree angles, which is what helped us solve some of those previous problems. So this is all the time. Okay. Somebody would conclude that this thing's got to be a square because they notice that it has the four sides that are congruent. It doesn't have to be a square. It does look like a square, but it doesn't have to be a square. We need more information than just four congruent sides. We would also need to have some angles that are right angles. So we could have a couple different things. One, we could say it's not valid right now that it's a square, so it's not valid. What we need is we need at least one right angle, which would make all of them right angles. So I'll just say that we need, I'll say we need four right angles, even though we just really need one, and then it would create four, but I'm going to say we need four right angles, and then that pretty much would make it a square. The other thing somebody could do is they could just tell us that it's a parallelogram first. No, that wouldn't do it, because then that would just make it a rhombus still. So yeah, we really need those right angles to make it a square. Okay. Alright, so now kites and trapezoids. Okay, definition of a kite. So quadrilateral, so of course it's quadrilateral, that's why it's in this module. So it's quadrilateral, let me just abbreviate. So quadrilateral with two pairs of adjacent sides, congruent. Adjacent just means right next to each other. Right beside. Okay, one of the big properties of kites that helps us solve is that the diagonals are perpendicular. Diagonals are perpendicular, like a rhombus. Remember that property for the rhombi. Okay, trapezoid. What is special about a trapezoid? It is a quadrilateral with one pair of parallel sides. One pair of parallel sides. Okay, so remember what that kind of looks like. That just makes a trapezoid there. Okay, definition of isosceles trapezoid, that would mean that it has congruent legs. So it has congruent legs. So it would look like this. It would have the parallel, the one set of parallel sides, but then it also has these legs that are congruent. Okay. The properties that this has is that it has congruent diagonals, just like a rectangle has the congruent diagonals. So does the isosceles trapezoids. So do they. So these are congruent. And then they also have congruent base angles. So congruent base angles. And actually, so it's like this. These are the base angles. These are congruent. And actually, because those are congruent, then these are congruent as well. Okay. Alright, so let's get solving here. So the kites are kind of like the rhombus as far as the problem solving goes, because the property that helps a lot for this is that the diagonals are perpendicular. So let's go ahead and put the 90 degrees in there. So, well, let's say angle 1 already is 90 degrees. Okay, so that's 90 degrees, that's 90 degrees. We got 27, so we should be able to find angle 2 pretty easily. So just on your calculator, just do 180 minus 90 minus 27, and then you'll get angle 2. That's the super easy way to do it. So, I mean, that's the way I would do it. So, but anyways, if I was showing work, it would be angle 2 plus 90 plus 27 equals 180. Angle 2 plus 117 equals 180. Angle 2 has to equal whatever 180 minus 117, so 63. Yeah, so 63. And then these are just straight across from each other, and they're bisected there. So these are both going to be the same. So that's 63, and then angle 3 is also 63. Okay, this is a nice one. So the property that's going to help us on this one is, this is a trapezoid, and so it has the one set of parallel sides like this. And the property that helps is that, remember when you have parallel lines and you have a transversal, this is like the transversal here, these angles are called same side supplementary, or same side interior, which are supplementary. So let's say the property is same side interior angles are supplementary. That's a great property that helps us on this one. And so that kind of draws into our knowledge, you know, from the past with the parallel lines. Okay, so now if they're supplementary, that means we add them up and we set them equal to 180. Don't set them equal to each other because they're not congruent. So add them up and say they equal together 180. Alright, so now we combine like terms, use our good algebra skills if we have them, hopefully we do. So 6x plus 8x, that's 14x, and then negative 22 plus 34, so that's 12, equals 180, and then subtract 12, so that's going to be 14x equals 168. Tell me that goes in evenly. 168 divided by 14, 12, okay, beautiful. So x equals 12, that was it. Okay, find these, alright, let's see. Well, for this one, what you can do is you can draw a line straight down here. So that'll cut the kite perfectly in half. and then that will cut this angle in half. So this angle was 101, but if you divide it by 2, it's going to be 50.5. And then same thing for this one. If you divide that one by 2, then that's 24 degrees. So then you can find angle 2 that way, because now it's just a triangle. So this is a triangle, and they always add up to be 180. So just do 180 minus, I don't know, maybe the easiest way for me is to do 180 minus 50.5 minus 24. Just put that in your calculator. So 180 minus 50.5 minus 24. What did I say it was? 105.5? Does that seem right? Yeah. So 105.5 degrees, and angle 1 is exactly the same, because these are two congruent triangles. So angle 1 is also 105.5 degrees. And that first one was angle 2. Okay. Alright, I think we're getting there. We are getting there. Okay, this one, what will help us? Probably the fact that the diagonals are perpendicular again. So diagonals perpendicular. Also, obviously, that a triangle equals 180. Okay, you know this. Triangle equals 180 degrees, the angle measures. Okay. Alright, so let's set this up. So this guy here is 90. So just add up those three angles. So that's going to be 2x plus 10x minus 6 plus 90 is equal to 180. Okay, now let's solve for x. So we're going to add these guys. So that's 12x. Combine those guys. So that's 84 equals 180. Subtract 84. 12x equals, what's 180? That should be 96, but I'll just do it anyways. Alright, so 96, so x equals, what's 96 divided by 12? That's 8. And what do we look for? X, that was it. Okay. Alright, now on Canvas I have posted all of these. Look at all these. These are great problems. So you can do these problems, and then you can look at the answers right here. And of course, if you're missing any homework, you should be doing it this way anyways, or the HRW, whatever you like better. But you have a lot of resources here. Alright? So if you practice, you can do well on all these quizzes, but you got to put in the time. And then last thing, bam, good luck. But if you study a lot and prep for this thing, you don't need luck. You just work hard. Alright, it's been a pleasure.